Welcome students in the organic chemistry lecture series. Today in this video we are going to start the chemistry paper 2 syllabus of your FY semester 1, and there is only one topic in your chemistry paper 2 syllabus for semester 1, and that is stereochemistry. So this syllabus is very new for you. You are not aware about the stereochemistry aspect of chemistry. So I will explain it in very simple manner so that you will understand the concepts of this stereochemistry. So I will directly start the point of your syllabus in this first topic. Now, first of all, what is meant by stereochemistry? That we have to understand. Stereochemistry means the study of molecules in three dimension. Study of molecules in three dimension, and you know what is meant by three dimension. We have to visualize, we have to imagine the molecule in a three dimension. We have to study the arrangement of atoms, arrangements of atoms in the molecules in a three dimension. Now whatever we are observing here on the screen, this is a two dimension, only x and y axis are there. While reading the book also there is only two dimension, that means there is only x and y axis. But if we see the molecule in space, if you see the models of the molecule, then the molecule is in three dimension. Now, what are these three-dimensional structure of molecule? How they are represented? All these things we have to see in this molecule. I will explain you with a simple example. If we consider a methane molecule, suppose CH4, all of you know the methane. So how we write the methane? We know that the shape of methane is tetrahedral, right? Tetrahedral. So how we write the methane? Actually, the tetrahedral shape is like this. Suppose there is a central carbon atom in this way. Suppose here is one hydrogen, right? Here is one hydrogen, here is one hydrogen, and suppose here is one hydrogen. Okay. Now, two of the hydrogen will be in the same plane which we are observing. Suppose I will write like this. Okay. These two hydrogens and carbons are in the same plane. But suppose this hydrogen is, if we represent it by this is called as wedge line, remember. And if we uh, represent this hydrogen by this way, okay, suppose this is one hydrogen atom, this is another hydrogen atom, this is another hydrogen atom, and this is another hydrogen atom. Now we'll see here, this is carbon, remember. Now here these two hydrogens, this one is on wedge line, this one is on rear line, and this is on the same plane. The meaning of this is that this is up, pointing up, or we can say pointing towards observer, pointing towards observer. Now if we are observing this molecule, then this hydrogen is pointing towards us. Now this rear line represents that this group is at the rear side, or we can say back side. Okay, rear side or the back side, or we can say pointing away from the observer, pointing away from the observer. And these two lines indicate that these atoms are in the same plane, we can say in the same plane. So in this way, molecule can be drawn in the plane of paper, or in this way molecule can be shown in a three dimension, we can say. One group is pointing towards you, one group is pointing away from you. The group which is pointing towards you will be shown by wedge line. This solid line is called as wedge line, remember. Okay, and this is a dot line, rear line. Okay, so one group is pointing towards you, one group is pointing away from you, and two groups are in the same plane. So this representation of the molecule in a three dimension is called as projection formula. Projection formula, remember, projection formula. Now the central carbon, now if this carbon is attached to four different groups, now here this carbon is not attached to four different groups, okay. Now but if the carbon is attached to four different groups, say like this, suppose this is A, this is B, okay, this is a C, and suppose this is D. Now here all these groups are different. A is not equal to B, B is not equal to C, C is not equal to D. All groups are different. Now in this case, this central carbon is called as chiral carbon, remember. Chiral or stereogenic. There are three terms: chiral, stereogenic and asymmetric. Okay. So if the carbon is attached to four different groups, then it is called as chiral carbon, or it is also called as stereogenic carbon, or it is also called as asymmetric carbon. Okay. So what is asymmetric carbon? The carbon atom which is attached to four different groups, and in three dimension we can represent the four different groups in this way. One group is here group C is pointing towards you, group D is pointing away from you, and these two groups A and B are in the same plane. But in the molecule, if there are more than two asymmetric carbon atoms, more than one we can say. Now if there are more than one asymmetric carbon atom, then this representation becomes difficult to draw in the paper, right? If there is only one asymmetric carbon, then we can easily represent in this way on the paper. That means one atom towards you, one atom back side, and two atoms in the same plane. If one asymmetric carbon is there, we can represent very easily, okay. But if more than one asymmetric carbons are there, then this flying wedge formula is not suitable to draw the structure of molecule on the paper. Remember, this is called as flying wedge formula, right? So in this way we cannot draw the molecule on the paper if more than one asymmetric carbons are there, okay. So if there are more than one asymmetric carbons are there, then we have to use different projection formula to draw the structures of molecule, okay. So I think you have understood what is mean by stereochemistry, or what is mean by flying wedge formula, how molecule is represented in three dimension if there is only one asymmetric carbon atom, right? So these things we have seen in this primary uh, video. Now further we'll see what are different projection formula used to draw the molecule on the paper if there are more than one asymmetric carbon atom. Okay, so we'll see one by one. Okay, now first of all we will see what is this Fischer projection formula. Okay, remember this method is developed by the scientist known as Fischer. Okay, he has developed this method of representing the molecule on the two dimension. Now I will take two examples how to draw the Fischer projection formula, and then I will explain how it is drawn. Okay, so see this lactic acid, you know all what is lactic acid. It is CH3CHOH COOH. Again see tartaric acid, it is OH, sorry, here is a COOH. Okay, COOH, CHOH, CHOH, and COH. So this is the tartaric acid. Now we'll see how these lactic acid and tartaric acids are represented in the Fischer projection formula. Now see here first this representation. Okay, now you will observe here that COH group is on the top and CH3 group is on the bottom, and then hydrogen is on left hand side and OH is on right hand side. Okay, now actually this molecule is like this. Suppose here is a central carbon, okay, then these two COH groups are on the rear side, COH groups on the rear side, and these two groups are on the upper side, or we can say pointing towards us. Actually, Fischer projection formula, the meaning of this Fischer projection formula is this. Similarly, this tartaric acid can also be represented, see, COOH, and then these two groups are pointing towards the observer, we can say. So OH, H, H, and here OH. Okay, so this is wedge line. You remember the meaning of this wedge line is that these groups are pointing towards us. Okay, now see here. Now, how Fischer projection formula is drawn? First of all, you have to select the longest carbon chain. Remember, select longest carbon chain. Okay. After selecting the longest carbon chain, you have to write the most oxidizable group on the top. Now, here you see here, longest carbon chain is of 3 carbon. Out of this 3 group, this COH group is highly oxidizable or oxidized state group. So we have written COH on the top, and the group which has least oxidized, it is written on the bottom. Okay. So oxidized, depending upon the oxidized state, we have to arrange the groups. The more oxidized group is on the top and less oxidized group is on the bottom. Okay. So first thing is select longest chain. Second thing is arrange group as per oxidation state. So for your understanding, I will write here order of oxidation state. COOH is higher than CHO, which is higher than CH2OH, which is higher than CH3 or alkyl group, you can say. So you will observe clearly that COH group has highest oxidation state, so it is written on the top. Okay, so this is about first select the longest chain, second arrange the groups as per oxidation state. More oxidized group will be on the top, less oxidized group will be on the bottom. Third thing is that the group which are on the horizontal lines are pointing towards you, remember, pointing towards observer. Whatever groups are on the horizontal line pointing towards us, pointing towards observer. You observe here that hydrogen and OH on the horizontal group, line, so they are pointing towards us. Here also hydrogen and OH, this OH and hydrogen are on the horizontal line, they are pointing towards the observer. And the groups which are on the vertical side, they are on the rear side. That means they are away from the observer. Okay. So you always remember that on the Fischer projection formula, the groups which are on horizontal lines are pointing towards you or pointing towards observer, and the groups which are on the rear, which are on the vertical lines, are pointing away from the observer. Okay. So this thing also you have to remember. So in this way, you can write the Fischer projection formula of any molecule if there are more than one asymmetric carbon atoms, or if there is only one asymmetric carbon. Why Fischer projection formula is needed? You imagine that if a molecule has 5 asymmetric carbon atoms, okay, then in simple flying wedge formula, which we have seen earlier, it is very difficult to represent the molecule. But if there are 5 asymmetric carbon, then very easily we can draw its Fischer projection formula. So this is the advantage of this Fischer projection formula, right? So you always remember that vertical line atoms are on the rear side and horizontal line atoms are on the towards you. More oxidized group is on the top, less oxidized group is on the bottom, and the point of intersection of vertical line and horizontal line, say for example this represents the carbon atom, remember. Okay, so in this way we can draw the Fischer projection formula. I think you have understood what is Fischer projection formula. In further videos, we will see another two projection formula. One is Sawhorse and another one is Newman. So that we will see in the next video. So till now, you remember only what is stereochemistry, what is stereogenic carbon, how it is represented in flying wedge formula, how it is represented in Fischer projection formula. So remember the Fischer projection formula of this lactic acid and tartaric acid. So we'll meet in next video. तब तक आप ये जो वीडियो है इसकी स्टडी करो. ओके, थैंक यू, हैव अ नाइस डे, विल मीट इन द नेक्स्ट वीडियो वेरी सून.